An open box, so that's a box without a lid, is to be made from a rectangular sheet of card measuring 16 centimeters by 10 centimeters. 4 equal squares are to be cut from each corner, and the flaps are folded up. Find the length of a side of a square, which makes the volume of the box as large as possible, and find the maximum volume. So we're talking about a sheet of card like this. We're then going to cut a square from each corner and fold these flaps up in order to make our open box. So if we let this be X, then remember all of these will be X because they're all squares and they're equal. If this side was originally 16 centimeters, when we fold up, it's going to fold from here to here. That's going to produce the side of our box. So it's going to be 16 minus 2x. And by the same argument here, this is going to be 10 minus 2x. So if we actually look at the box that we're producing, so it's going to look something like this, then when we fold up, it will fold up by x. This will be 10 minus 2x, and this will be 16 minus 2x. So the volume is going to be x, 10 minus 2x, 16 minus 2x. And we should perhaps expand that out. So that's going to give us 160. Take away 32x. Take away 20x, so that's going to be 52x plus 4x squared. So that's 160x minus 52x squared and plus 4x cubed. And we want to maximize that, so we'll do dv dx, and that will give me 160. Take away 104x plus 12x squared, and we want that to be equal to 0. So 12x squared minus 104x plus 160 is equal to 0. Now, I think we'll probably have the calculator for something like that. So let's have a quick look. Action, advanced, solve. What have we got? 12x squared. Take away 104x plus 160 is equal to 0. And that gives me either x is equal to 2 or x is equal to 6.6 recurring. Looking at these answers, we probably could have factorized this without the calculator, but we've saved time anyway by doing that. So let's have a look at these. This one here is not possible. And the reason for that is that if x was 6.6 recurring, we wouldn't be able to cut those flaps out of 10. It just wouldn't work. So we'll be cutting away more than we have. So the answer's got to be the x is equal to 2. So we've done the first bit. We've found the length of the side of the square. We could, we're not asked to, but we could do d2v dx squared, and that would be negative 104, add 24x, and that's clearly negative when x equals 2, so that indicates that we've got a max. So x is 2, we want the maximum volume, so the volume is going to be to 10 take away 4, 16 take away 4, so that's going to be 12 times 12, 144 cubic centimeters.